Word up, folks. How's it going? How are you guys doing? Hopefully, we're in a slightly better position than we were yesterday, and as I understand it, everyone is now up and running with their Pycharm and Pygame, and in theory, if you use the code that I pasted on Discord and whatnot, you should have something up and running. If I just run my game here, you should have something that looks like this. Yeah, we've got our ball bouncing around the screen here, and at the moment we can move our bat, but the ball still goes through the bat. Mine does not do that. Okay, what does it do? Have you definitely got all of the graphics that you need? Okay, so when you say mine does not do that, can you be more specific? I can maybe help you fix it. I want to make sure we're all starting from the same point here. I know Alex went and modified his so that he got some collisions in there and it's bouncing off the bat. That's great. It seems like it's loading, then nothing happens. So it doesn't crash. Do you get an error? That is odd. That is odd. And you've definitely got Pygame installed. Yeah, and you're not getting any errors down the in your Pycharm output. Do you get this message that says Pygame 1.9.6? Hello from the Pygame community. It says hello from Pygame. Okay. And you've definitely got the graphics, the ball and the bat PNG files, and they are stored in the thingamawhat's-it. Stored in your graphics folder. Yes. That is odd. And I don't know. I'm going to put it down to the fact that it's on a Mac, but I still don't know. You should get a window that pops. So you don't even get a window that pops up. There's not even a window that pops up with your. Not even a window that pops up with anything in. Right, I will do some further investigation here. Actually, here's. I'm gonna try. I'll send you a couple of commands on Discord, Amy. Try running them from the Mac command line. Although I don't think this is actually going to make much difference. Try it regardless. try them, see if it makes any difference. If it doesn't, we might have to do some further investigation. I think the issue stems from the fact that Pygame uses SDL, and there's some issues with SDL on Mac. I guess for the time being, you can follow along, and if you run into any sort of syntax errors, you can perhaps correct those syntax. I mean, it's going to be kind of whack trying to follow along without anything actually working. So yeah, I'm not entirely sure. Although if Jermaine got his working on a Mac, maybe Jermaine could help you out with some stuff. I mean, you've got Pygame installed, and that's obviously working, but there's something going on in the back end. It's probably an SDL issue. Okay. However, with that aside, what we're going to have a look at today is we're going to have a look at collisions. We're going to have a look at resetting the ball. And then I'm going to set you guys a challenge. I'm not going to walk you through the whole of this. Okay, I'm going to set you a bit of a challenge at the end, where you are going to develop your own class to add some blocks to the game. And to start off with, you're just going to add a single block, which is going to be destroyed when the ball hits it. And then once you've tested that and you've got it working, do you know what? Now, this is completely irrelevant, but for the past few days, when the sun has shone through the window over there, there's been sort of like a rippled effect on the wall in the shadows, and I've always thought, what on earth is causing that? And I've looked across and I've realised it's the masts and the rigging from my model of the Cutty Sark, which is in the window. I've just worked that out. That's totally irrelevant. Sorry, I went off on a bit of a tangent there. But yeah, so we're going to get some collisions working with the what's it called, with the bat at the bottom. So you'll be able to, in theory, play a very rudimentary version of the game where the ball will bounce around the screen, and if it goes off the bottom of the screen, it will reset. Now, you can have a play around with that, and what you could potentially do is every time you bounce the ball, you could increase the velocity so that it gradually gets faster and faster. Another thing that you can do is try and detect how close to the edge of the bat the ball was and adjust the relative velocities there. Okay, so I'm just going to sort of walk you through the basics, and then I'm going to set you the challenge of making those improvements. Okay, there was a certain method that needs to be called, otherwise it breaks. Right, okay, so here we go. If I just run the program, I get my ball bouncing. The first thing that we're going to do is we are going to fix it so that when the ball hits the bottom of the screen, it doesn't bounce. It's actually just going to go off the bottom of the screen and then reset back into the middle. Okay, now obviously that's going to break our game and make it unplayable to start off with until we've added some collisions, but that's the first step towards getting this working. Other things that we need to do, obviously we've got this mouse cursor on there. We probably don't want the mouse cursor in there as well, so we'll try and get rid of that mouse cursor. And then we will look into maybe putting some limits on the bat. So if you have a look here, it's going off the edge of the screen. Maybe we don't want it to go all the way off the edge of the screen. It's going to be a little bit of maintenance to get to the game to a state where you can actually call it a game. Okay. How can you get rid of that mouse? You just set the mouse cursor to be invisible. Simples. Okay, so So let's have a let's just quickly go through our code. What we've got so far: we're importing Pygame. We're setting up the local constants so that we can refer to them. We're setting up our own constants here with the screen width, the screen height. I've set this color as white. I might be able to define some other colors in there if I wanted to. And we've set up the FPS clock and there we go. We've got our sprite class. Now, in a more complex game, you might find that the sprite class ends up being fairly large. At the moment, our ball class and our our ball class is bigger than the sprite class. The back class isn't as big as the sprite class. Ordinarily, the sprite class would be the larger of all the classes. It would have things like rotation and stuff like that on there, but we're not going to handle that right now. So our sprite class at the moment handles things like loading the image in that it's going to be. It sets up its own rect. It's got functions to draw it, and it's got a function to set the position there. Our ball class inherits from the sprite class. It sets its initial position to be the middle of the screen. We might end up changing that. Don't know. It also sets its initial velocity to be static. We've got our move function, which determines how the ball bounces around the screen, and then we've got these functions to set the velocity and get the velocity. I think what I'm going to do is in my sprite class, I'm going to add. We've got a set pos method. It's only fair to have a get pos method as well, so we can use that. Okay, so if we say get pos, now we want to return. We don't want to return the whole rect. We just want a XY coordinate position, which is going to be the center of the rect where we're drawing it. Okay, so if we say return self.rect.center. Okay, when we call get pos on a sprite now, it will return whatever the current position is. Okay. Show the coordinates in the top left. Coordinates of what? The coordinates of the sprite. I mean, that's some functionality that you could definitely add. So we've added that now. We've got set velocity and get velocity. I mean, really, velocity should probably be in the sprite class rather than in the ball class. So what I might do is just move them around. But for now, let's just keep them where they are. Our back class basically does everything the sprite does. It's got its own unique set pos method here as well. Our game class was the most complicated of our classes. And it sets up the screen, it sets the caption for the screen, it creates our ball, it creates our bat, and it's got functions to reset the game. So resetting the game will set the ball back into the middle of the screen. It will set the velocity of the ball to 1010. Maybe you want to start it slower. Don't know. You could always change those. And it sets the bat position to the middle of the screen. Okay. Process game. Every time we go through the game loop, we are going to do the following things. We're going to check the events. So that's checking to see if the user has quit, if the user has moved the mouse. Obviously, if we had any other controls, like if we wanted to be able to shoot or something like that, we might check to see if the user has clicked the mouse button. But because we farmed it out to a separate function, it means that any additional things that we can put in there, we can just add here. Ordinarily as well, we would probably have separate event handling methods to do this stuff. So instead of having self.bat.setPos blah 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 down there, we would probably have a function called moveBat or something like that, which handles the specific type of movement. But this is a basic game, we don't need to worry about that sort of stuff. We've also got this function run. When we run the game, that starts the game loop running. Remember, the way the game loop works, and all games work like this, you check for user input, you update the position of the sprites on the screen, and then you update the entire screen. And you do that every time you go through the game loop. Okay. Obviously, if you're playing against the computer, there will be AI routines that it goes through, but it's the same. It's the same deal. I always say that the way a video game works, it's exactly the same to the way a board game would work, but instead of waiting for your turn to finish, the computer has his turn every 60th of a second. So that's that. So when we run the game, we reset the game, we set running to true, and then while we're running, we are going to fill the screen with white. We're going to go through the whole of our game process. So everything that's in process game, that's the step-by-step instructions for the computer, what happens during the processing of the game, and then we update the screen. And then at the end of the game loop, we tick the clock. Okay? So that should hopefully all make sense. Does anyone have any specific issues with any of that code as presented so far? Don't be afraid to ask questions about specific bits of the code. No, it's all cool. Right, good. Okay, so what we basically want to do is we're first of all going to edit our ball class. At the moment, this is the bit that determines whether the ball is bouncing off the top of the screen or the bottom of the screen. Now, one of these bits is the top, one of these bits is the bottom. So which of these two conditions here means the ball is bouncing off the bottom of the screen? Is it y is less than 0, or is it y is greater than screen height? This is, if the ball goes below 0, does that mean it's gone off the bottom of the screen? Or if the ball goes above the screen height, does that mean it's gone off the bottom of the screen? Which of those two determine the ball bouncing off the bottom? Excellent. It is the greater than screen height. Okay, and this confuses a lot of people because they're used to having 0 at the bottom on the y-axis and the highest values at the top, especially if they've used Scratch, the greatest programming language of all time. But those in the know that on the y-axis, 0 starts out at the top and it gets higher the closer you get to the bottom. Just out of interest, does anyone know why that is? Anyone know why y is 0 at the top of the screen and gets to bigger numbers towards the bottom of the screen? Top corner is always in the screen because the screen refreshes top to bottom. The screen refreshes top to bottom. I believe that's Josh that's just answered that question. Yeah, and that goes back to the old days of cathode ray tubes. The way that raster scan displays work is they start scanning from the top left corner, they draw a line, and then the gun refocuses down on the next line, and so on and so forth. So the screen refreshes from top to bottom. That is the order that the pixels update, and it's a throwback to the old days of cathode ray tubes. So we want to disable this bouncing off the bottom of the screen malarkey. So we don't care if the Y position has gone off the bottom of the screen. We are not going to bounce it, right? So we are going to get rid of that. We are, however, going to check to see if it's gone off the bottom. Okay, so we're going to have another if statement here. So if y is greater than screen height, what we want to do is reset the position of the ball. Okay, so we want to set that to the center of the screen. So we can say self.rect.center equals screen width divided by 2 and screen height divided by 2. Remember, we're using integer division here, so that we don't get any half pixels. And then we want to have this next bit in an else statement. Okay, so once we've done the bouncings and we've edited the velocity here, we then say, right, if it's gone off the bottom of the screen, just replace it in the middle. If it hasn't gone off the bottom of the screen, then replace it in the position according to our modified x and y coordinates. Does that make sense? No one knows if that makes sense. Yes. Yes, that makes sense. Good. We're not going to do a time. I mean, we could put a time.sleep in there, but that's not really the way that we would handle. If we wanted a pause before we reset it, we wouldn't use time.sleep because that would pause the running of the entire program, and the user might feel like it's crashed. So what we would do is use something called dead cycles, where we would start a timer, and we'd still have those cycles going around, but it would count down a number of seconds. And the way that we'd do that would be by using Pygame's built-in clock. So that's a more advanced feature that maybe we'll look at once we get the rest of it all up and running. Okay, so if we run it now, we've got this really annoying game where the ball constantly falls down from the top. It falls off the bottom of the screen and then it resets itself. Oh god! And it doesn't matter whether or not the bat is underneath it or not, because we haven't got any collisions in there. It's the most frustrating game of tennis you will ever play. Okay, how annoying is that? Yeah. So. Do not panic, though. We are going to get our collisions in here now. Okay, you have an error. Okay, what is the what's the error that you are getting? Attribute error. Pygame.rect object has no attribute center. You got to spell it ER, not RE. Yeah, it's the American spelling. Okay, and let's have a look now at how we can add collisions. Now, the way that we're going to handle collisions is we are going to get the game to say to the ball, are you colliding with the bat at the moment? Okay, and if the ball is colliding with the bat, then we're going to invert the ball's y velocity. Okay, now we could potentially have a function which is called bounce, which will do it for us. Maybe we'll go back and fix that later. But what we are definitely going to need, after we've checked the events, we are going to need to check the collisions. Okay, so we're going to say self.check collisions, even though at the moment we don't have a check collisions function. Never fear, let's create one. Def check collisions. Gabe, can you be sensible, please? So we're going to check the collisions, okay? And for our incredibly basic game at the moment, the only thing that we are checking is whether the ball has collided with the bat or not. Now obviously later on things get a little bit more complicated because we need to check to see if the ball has collided with the block. And not only that, we need to check to see if the ball has collided with any number of blocks, right? So yeah, that's correct. That is not how you spell collisions. There we go. Thank God for Owen, my IDE helper there. Okay, so in order to do this, we are going to use the collide rect function. Okay, so let me remember how this works. Self.ball. Sorry, we're going to say if self.ball do you know what? I just need to go and double check something here. Let's go to the Pygame collide rect. I think we might need to have a collide rect. Collide rect. Test if two rectangles overlap. Returns true if any portion of either rectangle overlap except the top or bottom. So collide rect. So what we are going to need. Remember when I said that get pos. We might need a get rect function in our sprite. So let's do a self dot get rect here in our sprite class. Sorry, not self, def get rect, and that's going to pass self, and we are just going to return rect, return self dot rect. Okay, we need to be able to get the rect of the sprite in order to check the collision bounds of that sprite. So all I've done is added a get rect function to our sprite. That's fine. Okay, so now that I've done that, my check collisions. I can do self.ball.getRect.collideRect self.bat .getRect like that. Now this is a reasonably complex line of code. George has just asked the question, why can't you just do ball.rect? You can. I could do if self.ball.rect, but that breaks something. What's the word beginning with E? My year 12 students, you'll be able to tell me. Why is that a bad thing? Not entropy. It does begin EN, though. Ding, ding, ding. No one knows? Man, I'm going to have to drill this into you some more. Begins ENC. Encapsulation, yes. Right, so for those of you who are unfamiliar with the concept of encapsulation, encapsulation is making sure all of the data about a thing remains with that thing, right? And you shouldn't be able to just reach into a class and pull out bits of its information, right? There should be specific methods that allow you to get that information. In the same way that it would be considered rude for me to reach into your brain and pull out your name, compared to me just saying, hey, what's your name? I almost said, hey George, what's your name there, but then that would have been a silly question. But the point is, in Python, it's kind of weird because you can just access those bits. In most programming languages, the class attributes will be set up as private. You should only access class attributes through get and set methods rather than reaching in and getting them directly. It means that we can control the way that this data is accessed. It reduces the chance of data corruption and other issues occurring. Right? So let's have a look at this. We've got self.ball.getRect. That is pulling out the rect of the ball. So that is the bounding rectangle that goes around the outside of the ball. Okay, and then because that is a Pygame rect, it has a function called collideRect. Okay. Now, what collideRect does, it checks to see whether that rectangle is colliding with another rectangle that you are going to pass to it, right? And so we've done bat.getRect. That returns the bounding rectangle of the bat, right? So if the ball's rect is colliding with the bat's rect, then that is going to be true, okay? Otherwise, it's going to be false. So if it's colliding, then we can bounce the ball in its y direction. Make it bounce upwards, right? Simple, in theory. Let's hope this actually works, right? So what we're going to do is we're going to say self dot ball dot set velocity. We need to set the x velocity to be whatever its current velocity is, and the y velocity to be whatever its current velocity is times -1. This is a place where a bounce function might be better. In fact, I'll show you the long way, and then we'll add a bounce function, and we'll just make it a little bit easier. So we can say self.ball .get velocity 0, self.ball .get velocity 1 times -1. Okay, and that is a reasonably confusing looking bit of code. Let's just double check that it works. Yay! I got some bouncing, right? My ball is now bouncing off my bat. Hooray! Okay, and if it misses, oh look, it goes back down to the bottom. Okay, so bonanza. There's some basic collisions. Okay, I don't know if you just noticed that slight issue that was caused there. It's a rare occurrence, but it is a bug nonetheless. I'll see if I can make it happen again. It's all about getting the right... You see, the thing is, we're checking to see if the ball collides with the bat. And there might be situations where the ball does collide with the bat, but it collides with the bat after it's past the point where it can bounce back up. Usually it's when you sandwich the ball between the edge... I'm pointing at my screen here, you guys can't see that. Usually it's where you sandwich the ball between the edge of the screen and the side of the bat, and it ends up sort of like bouncing inside the bat. We'll have a look at how to fix that a little bit a little bit later on. But for now, we have some basic collision. Okay, it's nothing to write home about, but it does the job. Okay. So yes, the ball glides through the bat. Like I said, there's some issues to work out. Okay, it just means tweaking our collision code a little bit. Okay, so rather than making it bounce off the bat, we would set up something called a collision rect, which is the area upon which the ball can actually bounce. But we'll worry about that later on. Okay, these are all refinements that you guys can put in there. Okay. Now then, I don't like this code here. I think that looks a little bit messy, and so what we might do is set up a bounce function inside the ball, so we can just do self.ball.bounce. It tidies this up a little bit. Okay, so if we go to the ball here, we can do def bounce. We could specify the axis that we want to bounce on. Maybe, so we could say bounce on Y or bounce on X or bounce on both. Yeah, okay, let's do that. But before I do that, we're going to say X equals, I don't know whether this is going to be, let's say axis X equals 0, axis Y equals 1, axis both equals 2. Okay, we're going to use these constants so that we can easily read our code a little bit. Okay, I'm getting a billion text messages here. I don't know why, it's really bothering me. So going to put my phone over there. So we've got our where's our bounce? Here we go, bounce. We're going to say if bounce. If axis equals axis X, self.velocity 0 times equals 1. Times equals minus 1. Aleph axis equals axis Y self.velocity value of axis both was 2. As I've been typing this, I've thought of a better way of doing it, but I'm committed now, so let's just soldier on with this, and then axis equals axis both there are way more efficient ways of doing that, FYI. I will leave it as an exercise to the viewer to come up with those better ways. I mean, for the purposes of this little program, we're not even going to use axis X or axis both at the moment anyway. I've just put it in there for future reference. Yeah, you could use a list comprehension to do that. There's an even more efficient way of doing it, using using bit masks and stuff, but let's not worry too much about that. So down here, instead of doing all of this malarkey here, all we're going to do is say self.ball.bounce axis y. We want it to bounce on the y-axis. Okay, that makes it a hell of a lot more readable. It also means that if you wanted to control the way that things bounce, you could just modify this function here. Okay, and so if I run that code again, we can see we're still nicely up and running. Okay, job is a good one. Okay, are we all at the stage now where we have a ball that bounces around the screen, and when it hits the bat, it bounces bounces back up, and when it goes off the bottom of the screen, it resets to the middle of the screen? Is there anyone that is not at that stage? Okay, so first of all, one of the things that you can try and fix is with the collisions. If the ball is bouncing off the side of the bat, we get some issues there. That's something that you could fix, but to be honest, I don't really want you to worry about that too much at the moment. What I'd like you to do is see if you can create a new class. Right? We've got a ball class, we've got a bat class, and we've got a sprite class. Create a class for the blocks that are going to go in the game. Okay, so the way that it works is you have a block which appears in your screen. In fact, let's just get my my thing up and going again. You have a block, and the block will appear in the middle of the screen. When you bounce the ball around, if the ball hits the block should bounce off, and the block should be destroyed. Right? So what I'd like you to try and do is program a class called block, which inherits from sprite and is drawn on the screen. You'll have to create a graphic for it as well. Okay, you'll have to create a graphic for it as well. To start off with, see if you can get that block just in the middle of the screen and get the ball bouncing off of it. Okay, then the next thing to do is see if you can sort it out so that when the ball hits it, that block disappears. Now, there's a number of different ways that you can do that. One way that you could do it is you could have a class attribute called visible, and if visible is set to true, then you're going to draw that block and have the ball interact with that block. And if visible is set to false, you are not going to draw that block or have anything interact with that block. Okay. You can reuse the back graphic if you want to. There's nothing stopping you doing that, but bear in mind that means all of your blocks are going to be the same size as the back graphic. That's fine. Or you can create your own with different dimensions. Not an issue. Okay. So creating a block is one thing. Another thing as well, and I'll post all of these instructions in the Discord. Another thing that you can try. Notice here, when I move the bat off the edge of the screen, half of it disappears off into nowhere. See if you can get it so that when you move to the edge of the screen, the bat will move no further. Okay? That's another thing that you can do. And finally, see if you can get it so that when the ball collides with the bat, it checks to see how far away from the center of the bat the ball is, and adjusts the angle that it bounces off based on that. So if you hit the ball directly in the middle of the bat, it will bounce straight up. If you hit right on the edge of the bat, it will bounce at an oblique angle. Okay. If the ball is still going through your bat, chances are that you don't have your check collisions, or you might have created your check collisions function, but you haven't added it to the process game. Okay, so just double check that. I will put all of this code up as a file in the Discord, so you can compare your code to mine. Okay, but we've been on for almost an hour now. And it's time for you guys to do a little bit of thinking. Now, bear in mind, I'm not expecting you to get this all up and running straight away. Okay? I've given you 3 different tasks to sort out. One of them is the creation of the blocks for the balls to bounce off. The second one is limiting the bat so that it doesn't go off the edge of the screen. And the final one is adjusting the angle of the ball depending on where it hits. Yeah, you could also, that's another thing that you could do if you wanted to. When the ball goes off the bottom of the screen, you could make it spawn in a random position, or you could make it spawn with a random velocity. It is entirely up to you, okay? But you've got the fundamentals of a game here, okay? It's not quite where it needs to be, but it works, and there's very few bugs, which means it's better than anything EA has released. Okay, so does anyone have any misgivings over the challenge that I have set? Do you all have a idea in your mind roughly where you think you might want to start? Okay, Gabe is confident, that's good. Alex is having a stroke by the looks of things. Ollie seems alright, Jermaine is confident, and Jack, good. Wickety-doo-dah! Right, in which case, I will get this code uploaded to Discord. I'll end the stream, but I will still be around in Discord so that you can ask questions, so that you can sort out the any issues that you have. I will be around. Okay. Wonderful. Thank you very much, everybody. Do you want some music to play us out? How about that? How about this? Right, that's it. Bye.